Okay, so I've posted in the link. We've just had some problems that my software was telling me it was streaming, but obviously, and YouTube was saying it was streaming, but YouTube wasn't displaying anything. So I've set up a new one. So if people could tell me if they're seeing that all right. All right, that's good. So this new link seems to be working. I will try to put the new link into here. That's gone. No, they're not going to let me edit that one. All right, if someone could check that link got up onto the YouTube chat so that people can move from the old YouTube link to the new YouTube link. And I'll try to put the link into the event on Meetup. Nope, it's not going to let me make that change on Meetup. All right, well, let's get started. And just let me know if you're having problems. So I've got a link to Google Colab here. And I'll start again. So my name's Tim Cummings. This is an absolute beginner session. So if you've never seen Python before, this is one for you. So sorry about the technical issues, and I'm not sure why it wasn't streaming up to YouTube. But we're going to use Google Colab for this session, which is a great way. It's a very powerful tool. People use it professionally all the time, but it's also great for beginners because it's interactive and you can learn from typing things in. You get immediate response on how Python will react. And that's the best way to learn how a programming language works. So Google Colab is free for anyone. We don't have to install any software on a computer. You just need a Google account and obviously internet access. I've got the link here. If you click on that link, it will open up a new Google Colab workbook. And you'll be able to follow along as I run through the session tonight. It'd be good if I could have a few more people say that they're seeing. I've got Ashok has told me he's seeing it okay. He's told me on Slack. But if other people are also seeing it, that would be good. Yep, I can see it. Okay, so a notebook. The first thing you want to do is click on this copy to drive, and that will save the notebook in your Google area, and it will allow you to make changes to it, and you won't affect anything on the original. So I'm going to do that first. I'll create a copy, and that'll open up a new one. You'll see it'll get a new name, and the name will have the word copy in it. And so this one is the one I'm also going to share this link to you, with you, and that way you'll get all the changes. So the other one will be the link for you wanting to look at the original, and this will be all the changes that I've made through today's session. So I'll copy that link and I'll paste that up on Slack, and I'll also paste it in the YouTube chat. So I better find the YouTube chat. All right. Good. Everyone's saying that they're seeing things. That's great. All right. So these notebooks are made up of text cells. So this is a text cell here, and she's got a nice border around it. And then further down here we get these code cells. And at any point we can add in extra code cells and extra text cells. Oh, you see here it says copy of meetup127 functions. And that's just, this is one that you can use and make changes to yourself. You can also use this link to pull in the changes that I've typed in. All right, well, let's get into things. So the first thing, we'll just learn a little bit about how to use Google Colab and Jupyter Notebooks. The first thing is how to get help, and you can use the question mark, and I've just commented it out. So comments are the lines that have got start with this hash sign in Python, and here we use the question mark to get help. So question mark is for IPython help. So IPython, Jupyter Notebooks, Google Colab, they're all pretty much the same thing. And straight Python is another thing that you can use when you are writing programs and saving them in files. So for IPython and Jupyter Notebooks and Google Colab, we can use the question mark. And now I've run this cell. I could have clicked on this play button here, or you can type Control Enter to run it, or Shift Enter, and that will Shift Enter runs it and jumps down to the next cell. So I actually type Shift Enter in this case. So here it brings up the help on the right hand side. You would have seen that there was a bit of connecting time here. The very first time you do something, it's quite slow because it's Google is setting up a whole computer area for you to work in. All right, so that's how to get help. You can also do question mark on particular commands, but we'll look at that later. So let's have a look. What is coding in Python? It's really just writing some commands down, and then the computer will read each command and execute it one by one. So for example, we could write a command print 5 plus 3, and that's a Python command. And if I do Shift Enter on that, you see it prints the value 8 to the screen. All right, I'm just checking that there's any questions so far. None yet. Okay, so this is really just a single line of a Python code. These are all lines of Python code as well, but they're just comments, so they don't do anything. Now that works in straight Python and interactive Python. And you can work in Python scripts, but when you're using IPython, you don't even need to put the print in. So here we can just type 4 plus 5, and it calculates 9 for us and displays the result. Within one cell, we can put several commands. So we can do print 4 and then print 3. So we run that. Now you should be able to run these as well. You can click these little play buttons, or you can press the keyboard shortcuts, Shift Enter or Control Enter. You can also decide, say you want to try something new, you can click on code and you go, well, I've tried print 4 and print 3, but what does print 2 do? So you can type in print 2, Shift Enter, and it displays a 2. So there you go, you've written your first line of Python code. Now when you're running IPython in these cells, only the data on the last line is displayed. So remember I said you didn't need to do a print command for 4 plus 5, and here we've got another one, we've got 2, we've got 1. So let's run this script. It only displays the last one, which was 1. It doesn't display the 2. So if you do want multiple lines of output from a single cell in a Jupyter Notebook, then you'll have to use print statements just like in straight Python. All right, now we often want to store values in memory, in Python, and we call those areas of memory variables, because we can change the values that are in them, and we give those memory areas names, and we can just make up names as we like. So we'll call this one X, and we'll put in 3, and we'll have another one Y, and in that we'll put in an expression. And our expression, we could have put in 4 plus 3, or we could put in a number 1, or we can actually put in a formula that's in with respect to another variable. So we can use X, and it will give us the value that we stored in X. So here X equals 3 stores the value 3 in X, and then Y equals X times X minus 4 times X plus 4. That'll go, well, X is 3, so it'll substitute the value 3 in there, so we'll get 9 minus 12, which is minus 3, plus 4 is 1. And then we'll print out the result. X equals 3, Y equals 1. Now I've used a fancy form of the print statement here using a thing called an F string. And an F string, as your normal string here, is enclosed in double quotes, but we put the letter F out the front, and that converts it into an F string. And what the F string means is if it finds any of these curly braces inside the string, rather than displaying the curly braces, it'll actually evaluate that expression. So it evaluated X and realized X was value 3, evaluated Y, which was value 1, and so it's printed out this string, X equals 3, Y equals 1. Now it's a little bit complicated for an absolute beginner to see something like that, but I think you're going to understand what it is. If you don't, let me know, and I'll start using a more simpler technique. But it's a really good way of displaying values of variables in a way that we can understand in the display here. And you can also put lots of formatting in there as well. All right. Now we can calculate X, Y for different values of X, and put all these X and Y values into lists. So lists is a nice Python feature for storing a bunch of numbers. So here's how we can create it. Now when I say tonight is for absolute beginners, I'm pulling on a few things that we've used in other absolute beginner sessions, but I'm happy to go over these again if you're not understanding them. But I just normally get a lot of people who are quite experienced coming to these sessions, so unless I've got absolute beginners, I will jump ahead just to keep them entertained as well. All right, so let's create a list. A list is designated by these square brackets. So we use a left square bracket and a right square bracket, and that's an empty list, and list of Y is another empty list. We're going to start off with X equals 0. Okay, we're going to create a loop here. So this is a for loop. So if you've used other programming languages, you'll be familiar with loops. Now the way a loop works, and what Python does, is it knows what's in the loop by everything that's indented. So all this stuff is indented, so Python goes, yep, it's in the loop. We don't have curly braces showing where the start and end of the loop is. All we have is a colon up here that says we're about to start a code block, which is indented, and anything in that is going to be included in the loop. Even this bit, which is doubly indented by this if statement. So you can see I've got a colon here that's even further indented, but it's still part of this main code block. And so Python knows that we've ended the code block when we come to a bit of code that isn't indented, or in this case we've just come to the last line of code. So let's see what this does. So I is going to run through this 41 times. It's going to start off as X equals 0, 0.1, so I is going to be 0, 1, 2, 3, X is going to be I divided by 10, so 0, 0.1, 0.2, 0.3. And Y is going to calculate the value of this function, x squared minus 4x plus 4, for all those values. And each of those values we've calculated for X and Y, we append them into our list, and so our lists just keep getting bigger and bigger. So let's have a look at what is in those lists by a couple of print statements here. This one here prints what the value of list X is. So as you'd expect, 0, 0.1, 0.2, 0.3, 0.4, all the way up to 4.0. And Y is 4.0, 3.61, 3.24, 2.89, and all the way up. And you'll see here, you really should have only 2 decimal places. If you look at that formula and you know a bit about how these things work. So that should be 0.81, but Python's using binary numbers here that's just displaying as decimal, and so there are some floating point errors that you will get in any programming language, and that's what these ones are showing. But it does a pretty good job most of the time. So in scientific applications this is not important. Maybe in accounting it can be important, and we can look later at some ways to get around this. Alright, so we created 2 lists. Now I'm going to show you how to use a third-party library to plot the values of x and y into a scatter chart. So to import a library, we use import and plotly.express, so that's the name of the library, and that's a pretty long name. If we want to just import it like that, we'd have to use plotly.express every time we wanted to use it, so let's give it an abbreviation. We'll call it px. Now plotly.express doesn't come with Python. You would have to install Plotly if you wanted it, but Google Colab includes a lot of the libraries that come with Anaconda. So you may have heard of Anaconda. It's a distribution of Python. It takes Python and then adds a whole bunch of these third-party libraries in as well that you might find useful. So if you've got Anaconda, you don't need to install Plotly. And similarly, Google Colab, we don't need to install Plotly, we can just run it. So we'll run this so that we've imported it. And you can see I can tell it's been run because it's got a number up there in the square brackets. And then we'll plot what it looks like. And there's a nice plot of our function going from 0 up to 4. And this is a Plotly chart. It's quite nice what you can do, like you can hover over any part of it. It tells you what your x and y values are. You can even zoom in, so we've selected the zoom tool here. So let's just select an area in our chart and zoom in on that. We can pan, so if I can select the panning tool, we can move the chart around. And I can even reset. I can reset it somewhere. Oh yeah, the home is home. I can reset the axes with this home picture. There we go. So have a play with that, with your chart that you've created. All right, now what were we doing? Oh yes, we were. We had this loop, and we had the function in there. And prior to that, we were typing in this function x squared minus 4x plus 4 every time we wanted to calculate it. So that's getting a bit cumbersome, and having to type it in every time we want to do it. So what we can do is we can create a function, and then every time we can just call that function, it will run this formula for us. So if we wanted to call a function f, we just put an f here. So we use def as a keyword in Python that says I'm defining a function. We give the name of the function, and then we can, in the parentheses, we put in any arguments there are. If there's no arguments, we still need to put the parentheses there, but and we can just leave it blank. But in this case, we want one argument, which we were using the variable x, but we can call our argument a here. So anything that we use for x gets substituted in there will go in as the value a, and it can calculate this formula. Okay, so I need to run this cell to define the formula, but that doesn't actually do anything. It doesn't call it, it just defines it. Now if we want to call the function, we can use the function name, which is f, and then in parentheses we put in the value of our arguments, or once again, if there's no arguments in this function, we just have to put the parentheses. So the parentheses say I'm calling the function, and inside the parentheses we put the value of our arguments. Now shift enter, it runs it, and it works out that the value at x equals 5 is going to be 9. So that's pretty easy, and now we can call the function for all different values. So I've given you a little task here. Call the function using an argument of 2.5. Now if you think you can do this, maybe pause the video, have a go, and then I'll do the answer. This is pretty easy, so I'm going to do the answer straight away. You just call the function name, you write the function name, then you use parentheses to say I'm calling the function. Then you put in the value that you want to use for the argument and shift enter, and that'll call it, and you can see 2.5, which is here, and I look that up on the chart. I can see y equals 0.25, and that's exactly what we got as the answer, 0.25. So I've got the solution here for you, and in this case I've shown how to use an f string to display the answer after calling this function. So f of 2.5 equals 0.25. Okay, now Python is a dynamically typed language, which means that we can put different types into these variables at different times, and it will just work with that different type. And here's an example. We've got 3 is an integer in x, and we can call a function with x, and we'll use this type function. That's just our label. This is where we're calling it, type x, and that will tell us what the type is. Now I'm just going to write a little bit of code up here. So here we had x equals 2.5, and I can find out what the type of 2.5 is just by calling the type function. It's a built-in function of Python, and it'll tell me it's a floating point number. Or if I had just 2, it's an int, or I can put a variable name in there, x. Alright, now when I'm printing it, it prints slightly differently, which doesn't look quite as nice in my view. It prints class of float. So if I want to get rid of this class, what I have to do is call the I want to print the name of the type, not all this other detail about the type. So Python's got this way of doing that. I put the dot name after the type, and it'll just print float, which is a nice way of looking at it. So that's what I've done in these print statements down here. I've called just the name property on type to find those. And here you can see I've put in a little bit of formatting, so I'm teaching you a bit about f-string formatting. Anything to the left of the colon is the value, anything to the right of the colon is the format. So here I'm doing a 7-character string, and by doing that, let's have a look at the output. It lines up nicely. So you can see it's got 7 characters in there before I then put my own colon in, and then y. Alright, so that's the strings. Let's have a look at what the results are. If x is an integer and I pass it into my function, I get a result which is an integer. If x is a floating point number and I pass it into the function, I get a result which is a floating point number. So f of 3 is 1, f of 3.0 is 1.0. So you can see how Python it calculates the type that it wants to return the results in when it runs a formula. So integers, if you're in integers, it'll stay in integers for pretty much every operation you do, except division, because division can return a fraction even if you've got integers as both operands of the fraction of the division. Alright, so task 2, try calling the function with an argument of a different data type. Okay, and the suggested data type is decimal.decimal, and that comes from the standard library decimal, which needs to be imported. Now you have to get these it's case sensitive, so that has to be a capital D and this has to be a lowercase d. And to make it a bit easier for you in the task, I've already put in an import decimal. Now decimal is a standard library, it's not a third-party library, so every Python installation is going to have decimal that you can call, but it's not part of the built-in function, so you have to import it if you want to use it. So we've now imported it because we ran that cell, and we want to call the function. So to call it, we do the function name and then parentheses, and then we're going to put in this value here. So I'm just going to copy and paste that. And maybe we'll store the result in Y. Okay. And I need to display the result as well. So I can say what's Y. So Y is a decimal with the value of 0.81. And just to show you, if I use a print statement on that, it just prints the value. It does, rather than telling me it's a decimal. I don't need to know it's a decimal. All right, so 0.81. Remember when we looked before at the calculation of Y, when we used floating point numbers, it had a floating point error built in. But when we use decimals, there's no floating point error. We get exactly 0.81 as the result. So this is how we can get around those floating point errors. The downside is it's a little bit slower, but if you're just doing a few calculations here and there, you're not even going to notice the difference. It's just when you're doing lots and lots of repetitive calculations that you will see the problem. Okay, so let's look at the solution. So the solution has imported the library slightly differently. Here we imported decimal, and therefore if we wanted to call something that's in the library, we had to prefix the library name to what it is we wanted to call out of the library. Now if we only wanted to call one thing out of the library, which in fact is this class here called decimal with a capital D, we can just say from that library just import that class and nothing else. And that means that then whenever we want to use it, we can just use decimal without having to do decimal.decimal. The reason decimal uses values in strings is that if we didn't have it in a string, it would be a floating point number, which is stored in binary. And once it's stored in binary, we've lost that precision of the decimal number. So by storing it in a string, it doesn't do that conversion first, and the decimal class can use it with exactly the values that it's got. All right, so let's run this, and we'll see the difference between using decimal 1.1 and just floating point 1.1. You can see the type of X is a decimal or a float, and the type of Y is a decimal or a float. So the way Python works is it goes, if you want to multiply a decimal by a decimal, you'll get another decimal. If you add a decimal to a decimal, you get another decimal. And there's the value, which is like what we want, just 0.81. This is the floating point one. It's got floating point errors built into it, and it's a float by a float. Yeah, everyone understanding how these data types are working? All right. Rewrite our loop from before, which created list X and list Y, but this time calling the function. All right, so I'm going to copy and paste our loop that we had before. And paste it in. And now rather than putting this formula in, I can now use the function f of x, and then everything else stays the same. And let's print list y. Okay, you see I don't want print list y to be in the loop, so I've removed the indentation from that. So for the first 10, we're printing what x and y are, and then I'm printing all the list y values. So that's task 3. and it's just showing us how useful it is to use a function. Now let's have a look at the solution. So the solution is doing the same thing, but it's also creating the lists in a much more succinct way. It's using a thing called list comprehension. When they were designing Python, they realized that this sort of thing, code, is a very common thing that people will be typing. They'll initiate their lists to empty lists. They'll run a loop, and then they'll calculate some values, and they'll append those values into the loop, and then they'll end up with the lists that they want. So they've created this syntax which you create a list in this case. So we've put the square brackets there. That's those square brackets up here. We have a formula for what we want to store in there, I on 10. So I on 10. Where does I come from? I comes from our for loop designator, and so you put the for loop in here. Similarly for y, so we've got the for loop again. For y, it's a list, so we put square brackets there, and we just call the function f. Alright, so let's see if that does. The only difference, we're not printing out these first 10 values, but they were just really for debugging anyway, just for logging some values so that we can see what was going on. And this list comprehension worked as well. Alright, so we mentioned before about built-in functions. They're just functions just like the functions that we create. They are called by entering the name followed by parentheses, and any arguments need to be included in the parentheses. You can have variable numbers of arguments in these. So here, print is a built-in function. If I do print parentheses parentheses with no arguments, it prints a blank line to the console. It's a little bit hard to see, but that's a blank line that just got printed. If I didn't have the print statement there, we wouldn't see anything here. Now in this print function, I can pass in, you've seen before I was passing in numbers. We can also pass in a string of text, and strings of text are designated by putting quotation marks around them. As you've seen, we had our f strings, which had an f in front of the quotation marks. Those quotation marks can be single quotes or double quotes, and we can print, and that has printed hello, the string. Alright, task 4, what other built-in functions have we already used? So I want you to go back over all the code that we've done here and look to see if you can find functions. And the functions are easy to find because they'll often have these parentheses there. So here's print is one we've used. Append is a sort of function. Range is a function. So range is a built-in function. Append is a function that we're calling on an object of type list, and so that's a sort of function that's called a method. And here we did px.line. That's a function. It's not a built-in function. It came from a third-party library. Here's a function we created. Type is a function, built-in function. Decimal.decimal. Now this is sort of like a function. It's actually it starts with a capital letter as a convention for when we're using classes, and so this is actually creating an object of that type of class, and there's the argument that we're passing into it. Okay, so I've got a question here. Ashok has asked, what error message do you get when a function is not defined or not in the library? Well, it's very easy to test that. So say, for example, we spelt print wrongly. So we said print and parentheses, and it just says the name print is not defined. So it doesn't know what to do with it. And really that's That could be whether we're trying to call it as a function or whether we're trying to call it as a variable. Name parent is not defined. So that's what you get, and so the type is a name error. If you are looking at a function within a library, so say we're looking in the px library for parent, it'll give an attribute error because that dot says we're looking for attributes of that value or that library, that module, and it's saying it's got no attribute parent. Alright, so getting back to our solution for 4, range and type we saw. As this is range with 1 argument, the stop value when iterating from 0 upwards, so it goes up to but not including the value stop. And then we had type, which is a value with 1 argument. We had px.line, which has 2 named arguments. So that's right, these are named arguments, not positional arguments. So positional arguments you just put in the position inside the parentheses, and it works out which argument it is by its position, what order it comes in. But you can use named arguments by naming them here, and we'll look at that a bit later. Decimal, not really a function, it's a class, but it can call a function as it creates that instance. Alright, let's have a look at functions that don't need to have arguments. We looked at print before. We'll create our own one, and we're going to use something out of datetime library. So we're going to import the library datetime. It's a standard Python library, but needs to be imported to use it. And we're going to use, out of that library, we're going to use datetime.datetime, and that's a class in the datetime library that's called datetime. And just after I told you classes should start with a capital, we find one that doesn't, and that's just because it's been around for so long. It was before they came up with that convention. Alright, in that class we're going to call a function, a class function called now, which returns a datetime object, which is the current time. And so that's an object that we can then, on objects we can call method functions by using the dot notation, and we're going to call this string format time function on top of that, and that will format the date and time that we've created and display it. So that's what our function does. We're going to define our function to do this print, and then we're going to call the function. So that's defining it, this is calling it. And here we go. So the current year is 2021, the current month is 12, day is the 7th, 8:23 and 12 seconds, and that's in UTC time. Alright, functions can return values. So you saw our function f that returned a value. Our function showtime didn't return a value. All it did was did an action, which was printing something. So we're going to create a function called time zone regions that's going to get all the time zones that can be used in our Python installation and work out which ones, what regions there are. So let's have a look what we're doing. A time zone region is going to look like something like Australia/Brisbane. So we want the region which is Australia. We don't, and we're not looking for the what would you call it? The time zone within that region. So Australia is going to be the region. It's going to be before the slash, and then everything after the slash is going to be the time zone within the region. So the Brisbane is going to be the time zone within that region. So I'm going to use this index function to find out where the slash is inside my time zone. So first of all, I check that there is a slash at least, because some regions won't even have some time zones won't even have a region. And then I will add to my set. So set's like a list, but it's unique values only. I'm going to add this time zone into it's the region into the regions, and because I'm using a set, it means that I won't get any duplicates, and then I'll sort them and return the sorted values. And just if there is no slash in the time zone, then the whole thing is going to be a region, so I'll add that in there as well. Alright, there's a lot going on there, but let's call this function time zone regions and print the list of regions. So Africa, America, Antarctica, Australia. Okay, so that's given us all the regions that are in there. That was pretty quick how I went through that, but let's go through a task and that'll help us understand things. So define a function which takes one argument, the region, and returns the time zones in that region. Okay, so that's going to be pretty similar to this. So we're going to define a function. So we have to give it a name. So let's call it time zone for region. Time zones, because there could be more than one. And we're going to take one argument, and that's going to be the region. All right, I'll put a colon there to say start a code block. And inside the code block, I'm now indented. You see Google Colab automatically indented for me. If you're typing this, I'm not sure, Google Colab might default to 2 characters, and I may have set it to 4, or it might be doing 4 because you've got a copy of my notebook anyway. All right, so I'm going to use this function here to get all my time zones, and I'm just going to loop through them all. All time zones. So we've got a question here. Is there debug using step-by-step execution to show changes in the variables? Yes, so there is. The one I like using the best is in an IDE like PyCharm. So I use PyCharm Community Edition, and in that way I can step through step by step, and it shows me the values of the variables and shows me which ones have changed on each step that I've done. So that's really useful. Now in Google Colab, where we're pretty much doing one line per cell in a lot of cases, although when we define functions we have to really define it all in one cell. We can't stretch that definition of a function across more than one cell. So in that case we can't see values, but what we can do is we can put logging statements in if we wanted to see what the values were. So I might even put a couple of logging statements in here, or print. I might just do print statements because we've done prints, and that way we can see as we go through what the different values are. Okay, so for time zone that I want to find out what the region is. So I can use the same formula pretty much. So if there's a slash in the time zone, then I find the index, and then I calculate what the region is. So I'm going to use string slicing to say give me all characters up to but not including the slash. Alright, and let's put some logging in there to see what it looks like. Print, and we'll say, so we want to know what the time zone is, what the index is, and what the region is. And I shouldn't have called that region. well, let's call that time zone region. Okay, and I don't want to print this a lot of times, so let's just print it 5 times. So if, all right, I'm just going to run this 5 times. Okay. Equals time zone. All right, so now I can do my test if they're equal. Then I'll add them into my set of time zones. TZ. Okay, so I better remember to create that in the first place. And that's what I want to return, is the time zones. All right, now I want to call that. So let's see, list of, what did I do? I sorted them up there. I'm not going to bother sorting them. So let's just call it my time zones equals time zones for region, and let's look in Australia. And we'll print that. So remember, this is going to go through 5 times, so we might not even find any, but it's going to call the function time zones for region. TX, why did I type TX? TZ. Okay, so here's our logging. So time zone equals Africa / Abidjan. The index is the index of that slash is position 6. And if you look here, so that's 0, 1, 2, 3, 4, 5, 6. That's where it is. And so if we do a slice of that string, which is Africa / Abidjan, all the way up to, but not including 6, we will get a region of Africa. So that's a bit of logging there for you, but when we printed it at the end, we've got nothing because we didn't get to the Australian ones. So let's hide this. I'm going to just do Control / and that'll automatically comment out that line, and then I can do the whole lot. So that's a shorthand for the whole lot, or I'll just do the whole lot. And here we go. We've got the Australian time zones: Australian Broken Hill, Australian Victoria, Australia Canberra, Australia North, Perth, Lord Howe. So I didn't sort them, so they're all in all sort of order. Is there a pause? Okay. So is there a pause statement in the for loop? So, so I think you're asking for debugging. You want to pause as you go through. What you could do is you could put an input statement in there, and then it would just do one at a time. So let's try that. so in this loop we'll say y equals input. I haven't tried this in interactive Python, so let's see how it goes. I think you put in here, press enter. So that's a sort of a pause, so I just pressing enter each time. And it's giving me the debug values as we're working through. So there's also in these loops you can do a break or a continue. So break will jump you out of the for loop. I want to cancel this, so you can see here I've got a stop button. So I can press that button and that interrupts it. It calls it a keyboard interrupt. And so that's stopped the code, and then I just comment out those lines that I don't want anymore. And run it again. And it gives me the list of, here we go, list of time zones. All right, so let's have a look at the solution. So this is time zones for region, and what I've done is I've recreated those functions before. So I've created a function called region for time zone, and I've created a function called time zones for region that calls region for time zone and just checks if they're equal. And I've also got another one, time zone regions, which returns all of the regions. And so both of these functions, so this is the function we defined first, this is the one we defined in our solution for this task, but both of them can use this region for time zone, because I noticed that there was code that was used in both. This code was used in both functions, and so there's a programming principle, don't repeat yourself, or DRY, dry. So if you see yourself repeating, then take the repeated code, put it into a function, and then call that from the different places that you're repeating it. And so that's the repeated code. We've put it into here, region for time zone, and then both of these other functions can call it, and we get our solution. Now notice a couple of other things that we've done here. We've put a string that's not stored in a variable straight after the definition of the function. We've done a triple quoted string, which means we can put new lines in the string, and it keeps going until we get to the end of the other triple quotes, triple double quotes. And this is called a doc string. And so if anyone does help on your function that you've written, they'll get this doc string back. So let's run this, and also let's call help on region for time zone. So we ran it, time zones for region Australia, we got these lists, and this time they're all sorted nicely. Time zones for region NZ is just NZ, so you can see that's an example of one that didn't have a slash in it. Time zones for region ETC are those ones, UCT, all the time zone regions. And then help on the function, so we called help here, and it returns our doc string. It says, this function region for time zone takes a parameter TZ and extracts the region from a time zone. By using the same function in time zones for region and time zone regions, we improve the consistency of data. And now if you're going to use time zones, I'm just going to warn you, be a little bit careful using these ETC ones. They're not exactly as you think. UTC is probably the one that makes a lot more sense, so don't use the ETC ones. So for example, if I was looking at these 4 different time zones, UTC, well in fact UTC is always Greenwich Mean Time or Universal Coordinated Time. ETC is GMT plus 10 is actually means you have to add 10 hours to your time to get UTC. It's not 10 hours ahead. So if you wanted the Australia-Brisbane time using ETC format, you'd use ETC/GMT minus 10. And you can see that gives you the same time. All right, talking about doc strings, help can be called on built-in functions. So print is a built-in function, and you see when I put print in there, I put print without the parentheses. If I put parentheses in there, it would call a function. I don't want to call a function. I think I don't want to call that function. I want to just use that function. I want to refer to that function in my help statement. So in that case, I don't put the parentheses on the print, but I do put the parentheses on the help function. And you can see what it's telling me here. Print, I put some values, and it's also got some named arguments here, a separator, an end, file, and a flush, and it tells me how I use them. Right, so the arguments to a function can have default values. Oh yeah, so this is defining what a default value. The default separator is a space. The default end value is a new line, and that's how you write new line in Python in a string, is \n. It tells me file is sys.standardout, and flush is false by default. But you know, you hardly ever use those things, but separator and end you can use quite frequently. You will normally write functions with named arguments, and those functions can then use those arguments as both minutes equals can use them both as positional arguments or as named arguments. So if I define this function here, I've got minutes equals, I give them the default value. I want the default value to be 0 for each one, and when I call it, I can call it using positional arguments. I can call it using named arguments. When I use named arguments, I can change the order around, or I can use positional and named. But if you do positional and named, you have to do the positional ones first and then the named ones second. So let's just check if that worked. Yep, they all gave the same answer, 1935, which is 32 minutes and 15 seconds. All right, expand total seconds to take 3 arguments, hours, minutes, and seconds. All right, so we define total seconds. And when I define it here, it's a second definition, so it'll overwrite the first definition. And really I just want to return hours times 3600 plus minutes times 60 plus seconds. Okay, and good old autocorrect. All right, let's just try that. 1, 32, 35. That worked. 555. Let's have a look at a solution here. Pretty much the same. The solution's put in a doc string, which is nicely describing what the parameters are, which is a good idea. And we've called it different ways. Yeah, positional and named, all named, named and using a default. And with the hours of 1, they get 5535, and they use different numbers than I did. Yep. So what are we going? Well, one more task. All right, define a function which converts temperature in Celsius to Fahrenheit. Okay, pretty easy. So let's see, define Fahrenheit, and we'll take a value which is in Celsius, and we'll just return Celsius times 1.8 plus 32, and we'll call that. height of 100 degrees Celsius should be 212 degrees Fahrenheit. There we go. So hopefully you've got an idea how to write these functions. They're very useful, can save you a lot of typing. They can make your code more less error prone, because when you're doing the same thing in more than one place, you know, if it's always calling the same function, then it'll always be done the same way. Let's have a look at the solution here. The solution actually put a print statement with some formatting in there, show you how to do formatting to 2 decimal places and floating point numbers, and 7 characters wide, so the decimal points all lined up. All right. So let's see. I see Vincent Reddy. He spotted my mistake before I did. Well, thanks, Vincent. And no other. Oh, okay. Yep. So we've got another question here. Is there referential argument in Python? That's a pretty good question. Yeah. So we're passing values in here, and so the values are being used in the functions. But if you wanted to pass in something by reference, then you'd have to use what's called a mutable data type. Let's see. So a dictionary is a mutable data type. So if I create a dictionary, and what it is, that's a bunch of key value pairs. So let's call x equals 45, and then I'll define a function that is called change x, and it takes in a dictionary, which I'll call dict, and then it can set the value of x. Let's just double it. Okay, so let's try calling that function. So we've defined d. Now we'll say change x of d, and then we'll print d. Key error d. Oh yes, I need quotation marks around that. And so now x equals 90. So you know, you could say that x is your you've got a reference, d is a reference to x, and so by calling this function we're able to change it by reference. So that's one way of doing it. There's also global variables, but I recommend against them if you can. So does that answer your question? All right, so next week we're going to go, this was functions for absolute beginners, but next week we'll be going to be looking at functions again and looking at some of the more advanced features of functions, and have some fun with lots of different data types that we'll be passing in to these functions. So if you've got any questions that you want me to answer next week, put them up in on the Slack channel, and I'll see if I can do that and give you some examples. But sorry about the technical difficulties that we had early on. We're broadcasting from Brisbane. In a couple of weeks we're going to have a Christmas party in Brisbane, so anyone who's local in Brisbane, I'd love to see you come along so we can have a chat in person rather than just online. Okay, thank you, and if you like it, subscribe and like the video, and I'm not sure what caused the problems early on, but it's the first time that's happened to me. I'll see you later.